In this lesson, we're going to solve applications and models with common and natural logs. The formula for the pH of a solution of hydronium ions is given by the logarithmic function pH equals the natural log of the hydronium ions substance, where this H3O plus, this hydrogen ion concentration. To find the pH of a certain agricultural product with a hydronium ion concentration of 4.2 times 10 to the negative 6, all we really need to do is to take the formula that we were given, which is that pH equals the negative log of the hydrogen ion concentration, and simply plug in the H3O plus place, plug in that value that you were given of that concentration. In this case, it's 4.2 times 10 to the negative 6. So once we plug that in, you could just use your scientific calculator easily to get the answer at this point. Do it all in one. So just type in negative, find the log key, and then type in 4.2 times 10 to the negative 6. Press enter, and you got your answer. It's as simple as that. And it's going to be the same way when you get to the problem that's on the quiz and the test and on the final exam itself. I wouldn't stress out about it. It's going to be in the same type of form where they're going to give you the hydrogen ions concentration in scientific notation form, and then you're asked to find the pH of that, and you just simply plug it in by plugging it into the pH of a solution formula. Now, of course, you can do it the long way, not suggested, but the fact that you have these two values that are being multiplied and it's a log, to write it in an expanded form, it would be negative log 4.2. And remember, when you expand it, it's going to be plus the negative log of 10 to the negative 6, and then add those two values and get the pH, but that takes much longer. You can do it all on one on a calculator. Now I'm going to go ahead and show you though that you can calculate it the long way, which is called the properties of logs way. But you can also just, since you have your calculator, just let the calculator do it for you, no stress. All right, so but doing it by hand though, one other way you can do it is you can go ahead and convert that whole scientific notation, convert it into standard form, and that would be the decimal that you see here. And you can type that in to your calculator as well, the negative log of that number, press enter, and it'll give you the pH. Or, like I said, you could use the properties of logs and expand it into two logs, find the value of each log, and then just continue to do the math. And we're going to subtract these two numbers. And then a negative with a negative in front is a positive. And the reason you had that negative is all we did was just, we took the negative out so that we could just get the value of what those two logs were. And then when you get it to where you have one number, a negative with another negative in front of it, you should know that it's going to give you a positive. So the pH is approximately 5.4. But, you know, why go through all of that if you're allowed to use your calculator, which you are on the test, all of the tests. So all you have to do is just simply, from the very beginning, type it in your calculator and you have your answer in less than a minute. Here's another application type problem. It says, suppose that the hydronium ions concentration of a sample of water from a wetland is 4.4 times 10 to the negative 6. Again, they gave it to you in scientific notation form, moles per liter. And it says to use the pH formula, use that formula so that you'll be able to classify according to the pH that you get out as your answer. Where does it fall in terms of the classification of wetlands? So if you get a value between 6.0 and 7.5, you know there's a rich fin. And if you get a value between 4.0 and 6.0, that's a poor fin. And then from 3.0 or less is a bog. So again, it's just simply, typing that scientific value in your calculator, finding negative log of 4.4 times 10 to the negative 6, press enter, and you got your answer in less than a minute. You don't have to go about doing the whole properties of logs and expanding it and then adding the two together and combining it to get your answer. Or even turning it into a scientific notation. That's another method, but you can get yours from the very beginning by just simply typing in negative log of that hydrogen ions concentration and just press enter. So with this output value, there it falls in that range of between 4.0 and 6.0, so therefore we can conclude that it will classify as a poor fin. Okay, so here's that same example. It's just showing you where it was solved using the properties of logs. Okay, so I want to see how you do on your own. So this is what it would look like on a test. So go ahead and see if you can find the pH of this hydrogen ions concentration. So go ahead and plug it in, negative log and 4 times 10 to the negative 4, and see if it's A, B, C, D, or none of these. Okay, so if you were able to plug these values in your calculator correctly, what you should have gotten it is a value of 3.40, which is D, and there you have it.
Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.